Hi guys, and welcome back to another Tech Minds video. So I just received a package from JLCPCB, and this contains 5 brand new PCBs. Now I'll only need one of them for this video, but let me tell you what it's for. Now a couple of weeks ago I made a video on a cool little VHF transceiver which is controlled directly from an Android application. Now if you haven't seen that video, then go ahead and watch it, but I'll cover most of it again in this video. However, that build was using PCB version 1.5, and the latest version which is available is version 1.7b, well, at the time of making this video. So what does version 1.7b provide that 1.5 didn't? Well, the improvements are all made to the onboard filtering, which should drop those horrible harmonics. Now this is what version 1.5 produced, running the output into a spectrum analyzer. Now while the second harmonic is not actually that bad, especially compared to some of these cheap Chinese radios we see around, PCB version 1.7b is supposed to improve on this. So let me show you first how I ordered these boards, just in case you want to do the same process. So first I head to the KV4P website and download the PCB files from the Github link. Now I just downloaded the entire repository as a zip file and then just uncompress the zip file, and the files that we need will be located in the PCB folder and then obviously 1.7b folder. Then just head to JLCPCB website, I'll leave a link below, and then first upload the Gerber file. Now you can do this by dragging the Gerber archive file to here like this. Once the file is uploaded, you should see an image of what the PCB looks like. Now just scroll down to where it says PCB assembly and turn this on. Now this is only if you want the components to be supplied and fitted to the board for you by JLCPCB. So I just enabled this and then click next. We now need to upload the BOM, which stands for Bill of Materials, which is essentially a list of components that's used on the board. So I drag the BOM file to here on the left, and then I drag the pick and place file to the right just here. Then click Process BOM and CPL. You'll notice here that the lower 3 parts are not selected, and I don't believe that JLCPCB have these in stock, so I just removed these and ordered them locally. Now these 3 parts are the ESP32 module, the SMA socket, and the DRA818 VHF module. Now you may also see a red notice on the right column, which is indicating that JLCPCB do not have enough stock for this particular component. So you have a couple of options here. You can either come back another day to see if they have stock, or you can search for a replacement component using the search button. Now when I say replacement, it has to be a substitute, i.e. the same values. But once you click that search button, the substitute should be displayed. But be careful here. You need to make sure that the package size is correct and the values are also the same. So for this item, it needs to have a 0402 package. The top item suggested is the 0402 package, and the component specifications look the same as the requested part. The only difference here is the tolerance, which is shown in percentage. Now the original part is spec'd at a 1% tolerance, but the suggested part is plus or minus 5%. Now if you do not have any other choice, then this should work, so I'll press the select button to the right here. Now when you click the next button, you will be asked to confirm not to place the parts that were not selected. That's the modules and the SMA adapter. Now I'll leave some links in the video description for those parts anyhow, so you can fit them yourselves. Those parts are definitely a lot easier to fit than the SMD components if you're not used to it. Now you can carry on going through the ordering process on the screen. Now yours will most likely come out cheaper than what's shown on the screen here, especially if this is your first time that you've ordered from JLCPCB. Now in my opinion, they're definitely my new favourite PCB manufacturer. They're cheap, great quality, and the delivery was super quick. So this is what the new boards look like up close, and here is a comparison with the version 1.5 board. We can see the filter network of components is different to 1.7b. Okay, so let's solder the components on the new board, and it's just the same as before. Now I like to just line up the RF module, solder one of those solder points, and then double check to make sure it's all aligned. Once it is aligned, I can just go round and solder the rest of the connections. Now the same goes for the ESP32 module. Solder one pin, make sure it's flush to the board, and then go around and solder the rest of the pins. You will need to trim those pins as low as possible to the board, as we need that space when it fits into the 3D printed case. So lastly, I'll just solder on the SMA socket. Now before we can use this board, we need to flash the ESP32 with specific firmware. And this is the same procedure that I performed in the last video, where I used the online flasher tool from the KV4P website. Now it's super simple, and you only need a USB to USB-C cable to go between your computer and the ESP32 module. Now if you didn't see this in the last video, you'll also need a KV4P Android application, which you can download for free from the Android Play Store. Okay, so now the important test. Will the spectrum analyzer show better results with this version 1.7b PCB? Well, the answer is yes. Looks super clean now, and definitely not going to cause any issues on those harmonic frequencies. Now, I received a lot of comments on the original video saying the same thing, that a $20 Chinese radio would be cheaper and better, but I think these commenters were missing the point here, no disrespect. Of course, if you only want a radio that transmits and receives audio, go for a cheap Baofeng. But this project is open source, meaning community contribution could bring lots of exciting features by use of the Android application. Now, one of the already included features is the ability to send and receive APRS messages, which uses an FM modulated 1200 baud AFSK transmission. Now, sending and receiving messages is super simple. Just need to enter the intended recipient's call sign and send the message. But here we can see a two-way communication using APRS messaging with a Yaesu FT3D handheld radio. Now, the radio modules themselves cover from 134 MHz to 174 MHz, and around 137 MHz you would see fax-like transmissions from NOAA weather satellites. So what's to stop someone creating a new feature on this, or an entirely new app that uses this hardware to receive and decode and then show these weather faxes? Maybe it's a hardware limitation due to bandwidth, but at least the idea is there. Digital modes like M17 could also be performed in software, if powerful enough, or even add in SSTV transmit and receive capabilities. So the beauty about this project is that we're only bound by our imagination and creativity within the supported frequency range and frequency modulation, i.e. FM. So another couple of questions I had was whether or not this module uses voice over IP. Well, the answer to that is no. The Android app does not require any internet or cell phone service to work. You only need internet to install the app, or if you do not have internet on your Android device, then you can download the APK from Github, transfer it to your device, and then sideload the application. Now, the other questions were regarding power output and battery drain. Well, the modules themselves, well, they're rated at 1 watt. And I have no idea how long the battery would last because it would all depend on your Android device's battery's capacity. And of course, there'd be many types of devices. Anyway, guys, just want to say thank you very much for watching. I really appreciate every single one of you that watch my videos and engage in the comments below. Until the next video, take care of yourselves, and I'll see you in the next video.